universal, or whatever this thing, ideal gas law or something, whatever this is called. And if you don't worry about the temperature, or say the temperature stays the same, then it'll be pretty easy to find the new pressure. Because then P2 should equal P1 times V1 over V2. Unless, because we could find the initial temperature, but then we don't know the final temperature. Yeah. What is this going to give us? This gives us V1, so 4 over, like 40 over 25 would be 8 over 5, 1.6. 1.6 times that would give you 1.6 times 10 to the 5th. Yeah, that'd be a simple way to do it. Now for part B, okay. Okay. So what we're assuming is something like this. This is at, let's say, room temperature at this pressure inside the piston. Now when you smash the piston, what's going to happen to the temperature of the air inside? Wait. Vivian. What's that? Yeah, it's good. I like how you just sort of came out with it. It's common sense, right? If you take something and hammer on it, it's going to gain energy. It's going to get warmer. Same, take a nail, hammer on it with a hammer sometime, and it gets hot. Same thing here. If you take air, smash it into a smaller space, it's going to get hotter. Now, what happens if you wait? If this piston is metal, like this, and it's in a metal sleeve, and you smash it up, the air's hot. Now you walk away, come back in 10 minutes. What happens? What happens to all the heat inside here? It's going to leave, right? When you touch something metal, why does it feel cold again? Remember we had this conversation? Because the heat does what? I'm sorry, the thermal energy does what from your hand? Yeah, it transfers, it leaves. It leaves as heat. It goes into the metal and leaves. That's why it feels cold. So when you smash this air, it's going to get hotter. If you leave it there, then the air will release the heat into the metal will release the heat into the environment. So then if you wait, that's why this actually works. Why can I do this? Because I'm saying in a metal container, in a conductive container, given enough time, these two temperatures will be the same. Okay? Now, if we go to part B, the question is, if this heat was not allowed to leave, so if T1 did not equal T2, if T1 did not equal T2, then, oops, reset. Let's see, let's go with A, B, or C. The temperature, and it's T1 and T2. Or sorry, we're looking at like P from part A and the pressure in part B. So what this means, if the temperature is not allowed to leave, so we hold the heat in that gas, is the pressure in part B greater than the pressure in part, is the pressure in part B greater than the pressure in part A? Is it the same as the pressure in part A, or is it less than the pressure in part A? So if we force the heat to stay in the gas, when we smash the gas, we leave that heat in there, is the pressure on that piston greater than part A, the same as part A, or less than part A? Jordan, did you put these away yesterday?
What is that?
It's a thermometer. thermometer. And then there are tongs. Yeah, so all those, make sure, take all the tongs back there, and then there's a drawer with tongs.
So these go with the other ones too?
Yeah, that goes with the other ones, and then see if there's tongs, take all the tongs back there, and make sure find a drawer with tongs, switch around.
It's in the back too.
34, nice, very good. Okay, I'm gonna quit while I'm ahead.
Well, that's 85 out of 80.
Yep. Okay. Good. So most people, 20 of you. What's that? D. Very nice. Oh, yeah. Very nice. So most people, 20 of you realize that the pressure will be higher than it was originally because all that heat. Now, here's the question. Why? Why? I need to stop this. There you go.